Hi students, let us make a complete detailed analysis on the subject digital electronics from GATE exam point of view. Basically, we are going to see the syllabus content of the course, its weightage in the GATE exams, and what are the pattern of questions we are getting in GATE exam. So these are three main factors, students. In preparation of every subject, you must should have. So what content you need to study, that is the syllabus, what is the weightage in these GATE exams, and what kind of questions are being framed. Because if you observe the last 30 years of question papers, so you'll understand in every year GATE exam, almost 85 to 90% of questions are of previous year model pattern. There are very rare cases where you get so much of new questions. So if you know the concept, based on what the past question papers are framed, so majority of the question you can attend. So if you see in a broad sense, students, every subject is ocean. If you take any textbooks of any subject, you'll find 800 to 1000 pages, and that to be one book won't be sufficient to cover all the content. So you have to refer 2 3 books. So every subject is ocean. So but GATE exam, it is very particular about what kind of questions are being framed based on what concept they are framing the questions. So that is what you should know. So these are the things we are basically going to discuss in this course. Students, digital is a common subject in electronics, electrical, instrumentation, and computer science branch. So this discussion which I am making, this is by considering all the 4 branches. So although if you see the GATE syllabus from the website, okay, so the syllabus are given in the form of a paragraph. But I have bifurcated the entire syllabus into 14 topics. So these 14 topics cover each and every point of the syllabus which is prescribed by GATE in all the 4 streams. So out of the 14 topics, students, the first 11 topics, so they are common in all the 4 branches, and the last 3 topics, it is not in CS. So CS people don't have to study these 3 topics. So it is only for electronics, electrical, and instrumentation. Okay. So you can see the chapters. The first one is number system. Second one is Boolean algebra. Third one is logic gates. Fourth one is K-map. Then combinational circuits, binary codes, latches, flip-flops, registers, counters, finite state machine, data converters, logic family, and semiconductor memory. Okay. So before I go into the bit more detailed discussion about all these chapters, let us have a study on the weightage in GATE exam. Okay. So you see, students, so this is what the weightage. So this is the very like the exact analysis we have made. So by observing the previous year question paper, this statistics is prepared. Like in a particular branch, like this table is for computer science. So for the last 10 years, from 2014 to 2023, we have done this analysis. Like in a particular year, how many 1 mark questions are asked, how many 2 mark questions are asked, and what is the total weightage. So this is what you need. And on an average, how much mark of questions you are getting in the last 10 years. So this data for all the 4 branches, computer science, this is for electronics, and then for electrical and for instrumentation, we have prepared this. Okay. But before I tell this weightage discussion, okay, so one thing, students, digital is one of the easy topic. Okay. So of course, like this is a relative term, which subject is easy, which subject is tough. It's a relative term. It all depends on your understanding on the subjects. But in general, if you see in a broader sense, so digital is one of the easiest topic. Let us agree this point. Okay. And this is one subject for which, for its understanding, you don't need any other background subjects. Let's say if you belongs to electronics branch, so you want to learn the analog electronics, unless until you don't know what is network theory, okay, how to manage voltage current in network, you can't understand a single point in analog circuits, or even some background of electronic devices are also needed. Similarly, if you are learning communications, without learning signal system, communication will be very difficult. So there are certain subjects which are interlinked subjects, but digital is not like that. Digital is independent subjects. At any point of time, if you learn this, you don't need any background information for this. And most of the cases, even the chapters are also independent. I mean, let's say there is nothing linked with combinational circuits and sequential circuits, or there is nothing linked with data converters and the number systems. So even the chapters in the subjects are also quite independent. So most of the cases, So, randomly any topic you want to learn, so you can learn that. So, but in every subject, you may not get that scope. Okay. So, digital is a easy subjects. Okay. But if it is easy subjects, but sometime again in every subject, students, so there are certain area from where you can answer all the questions very easily, and there will be some question in the papers, even though it is from easy subjects, it might be beyond your level. So sometime questions are also coming that way. We need to see. Okay. So if you see, students, computer science in the latest in 2023, 8-mark question has been asked. Two 1-mark questions and 3 2-mark questions. In 2022, it is 3 marks. In 2021, 6 mark, 7 mark, 4 mark, 8 mark, like this you see. So, there is no such very exact, like number like we have to get or we'll get every year 6 to 8 marks, not like that. So, sometime it is going as less as 3, sometime it is going as high as 8. Like this year it happened. And 8 mark also asked in 2019. Okay. So, if I take the average of all these 10 years, so it is coming 5.58 marks. And you see, students, so in 2017, 16, 15, 14, 21, we have multiple sets. So we have taken average of all these papers. So on an average, 5.5. So yes, generally while teaching the subject also, I used to say in CS, we are getting the question around 5 to 6 marks. But in GATE exam, every mark it counts, right? So you can't say it is less. So this is what in the analysis of computer science. So what are the questions they are asking? Okay, so I'll discuss now. So let us first complete this analysis for all the streams. Electronics, if you observe, students, on an average 8.47 marks we are getting. So around 8 to 10 marks of questions we are getting every year in the electronics branch. So sometime the weightage is as high as 11. Sometime the least weightage, if I see, this is 5 in 2019. Okay, so there is variation. Although in technical we are getting 72 marks in GATE exam, because out of 100, what is happening? 15 mark is going on aptitude and English, and then 13 mark is for maths, engineering maths. So this is total 28. So 100 minus 28 is 72. So 72 marks of technical question you are getting. So in this 72 marks, which subject will have how much weightage? There is no such restriction. So sometimes even some subject have 0 weightage also. In electrical, there is circular measurements. I think last to last year, so there were no questions from measurements. Okay, so sometimes situation is like this, but that is the worst possibility. But every year, almost every subject they are touching. Okay, so minimum around 3 marks and maximum around up to 10 marks also they are going sometime, right? So you see in electronics 8.47 is the average. So this is the exact data, students, by observing the last 10 years of pattern. So we came to this conclusion that on an average 8.47 marks we are getting in the electronics paper. Electrical, it is less, in fact least compared to all these streams. In electrical, we get 4.6 marks on an average. Actually, if you observe the syllabus of electrical, so it is analog and digital circuits. Okay, so combiningly from analog and digital, 10 marks of questions on an average we are getting. But if I speak specifically with respect to digital, so 4.6 marks we are getting. So again, the weightage is pretty random. So in 2022, you can see only 2-mark question has been asked. That means only 2 1-mark question has been asked. And the highest weightage I can see in 2014, the 7 marks. No, in 2014 it is 8 marks. So minimum it is 2 and maximum it is 8. In between you have every number 2, 3, 4, 5, 6, 7, 8. All possibility are there. So electrical weightage is less. And coming to instrumentation, its weightage is highest. The average is 9.11. So approximately 10 marks. So consistently 9, 10, 9, 10, 9, 10 we are getting, right? So in 2023, so 9 marks of question has been asked. Okay, so if I observe only this last year pattern, students, you see in computer science 8 mark they have asked, electronics also 8 marks, instrumentation 9 marks, and CS 6 marks. So relatively in 2023, the weightage is more compared to the average weightage what we got. Okay, so this is what the weightage is, students. Okay, so now the next thing is what are the exact content that somebody should focus in all these topics? So, students, generally, so one by one, chapter wise, let me discuss. So, coming to this number system, okay. So, in number system, what kind of questions or what is that area from where majority of the questions are being framed? So, number one is based on number system conversion. So, a number will be in one base, you have to get the number in its other equivalent base. So, based on that, so there are some tricky question also. If you understand the concepts and if you solve the previous year question paper, you'll understand, okay, conversions. In fact, the next series of video what you're going to see, which will be uploaded in our channel now. So I have covered many of them, okay. So first category of questions you are getting from the number system conversions. Second one is we are getting the questions from complement arithmetic. Complement arithmetic. Like, you have to, they will be giving you in 2's complement representation, these numbers are added. What is the condition of overflow, or in what case overflow is happening? And in complements arithmetic, we have some formula also. What is the range of numbers using n bits, using 1's complement method, using 2's complement methods, using sign magnitude methods. So like this, okay. So these are the two main area where questions are being framed. But to answer these, like each and every questions, you need to have very detailed study. I'm just telling you, so what is the exact pattern they're asking. So most of the time, if you observe the last GATE exam question papers, so questions are generally based on the number system conversions and complement related questions or complement arithmetic related questions. So this is what happens in case of number system. Now, what kind of questions we are getting in the Boolean algebra? In Boolean algebra, students, the first category of questions we are getting is Boolean algebra simplification. So, a expression will be given and they will be asking you to simplify the expression. So, there are some, logic like using De Morgan's law and using some standard law, you have to simplify the Boolean algebra expression. So, one model of question is Boolean algebra simplification. Second model of question is finding mean terms and max terms, directly or indirectly. So they will be asking you to find the mean terms and max term of a expression. Sometimes questions are being framed based on the concept of dual, self-dual, okay. Sometime Venn diagram and sometime switching diagram, okay. So generally, if there is a questions from Boolean algebra, so 99% of cases that question will belongs to any of these three category. Boolean algebra simplification, finding mean terms, max terms, that is then dual, self-dual, Venn diagram, switching diagram based questions. So this is what you get in the Boolean algebra. And in K-map, what kind of questions we get in K-map, okay. In K-map, students, again the first category is remains same like what we have in Boolean algebra. So first one will be, so they will be giving you a Boolean expression, you have to simplify that using K-map. Sometime instead of giving the expression, they will be giving you the mean term, max term combinations. So how to simplify that using K-map? So that is one model of question. Second model of question is to find the number of prime implicant and essential prime implicant. Okay, so if there is a question from K-map, so that question belongs to either this category or this category. So there is no third category in K-map. So all the 100% question belongs to these two category only. Next one is in combinational circuit, students. Okay, so what kind of questions we are getting in the combinational circuits? So first one is, students, you should have idea regarding the half adder, half subtractor, full adder, full subtractor. So they won't ask the direct questions, but so later while answering the question of multiplexer decoder, sometime this idea needed. So they will be saying design a full subtractor using multiplexer, design a half adder using decoder. So in such kind of cases, this knowledge is very essential. And one more thing is the ripple carry adder. So if you observe the last couple of years, there are many questions asked based on this ripple carry adder. So this is one. Second one is the multiplexer based questions. So this part having the highest weightage. If you observe the total number of questions in combinational circuits, okay, so 80% of the questions which are from combinational circuits, so that will belongs to multiplexers. Multiplexer is one of the highly weighted part. The questions are of very low standard, easy model questions, but weightage point of view, it is pretty high, multiplexers. So these are two major area and decoder up to some extent. Okay. So these are the things that you should study in the combinational circuits. Then after combinational circuits, you have the sixth topic, that is binary codes. Binary code weightage is almost negligible, or you can say nil. So you need to have some idea regarding the gray code. Sometime question in counters, so they ask related to gray code. Sometimes there are some questions, and basically hardly it's a very small topic, half an hour discussion. What is valid VCD code, invalid VCD code, a valid XS3 code, invalid XS3 code, gray code, how to convert a number from binary to gray and gray to binary. So this conversion you should know, how to convert a number from one code to other code. So that is what the question. But binary codes weightage is relatively very less, students. Okay, so like in every 10 year, hardly one question we get from binary codes. Okay. So, but in GATE exam, students, sometime when I give this list in the class, students ask me, sir, which topic is important? So we cannot say, because the weightage is pretty random. Sometime 2 marks, sometime up to 10 marks of question we are getting. So let's say it's a 2 marks. So you get 2 marks the weightage total. So maybe there are 2 1 mark questions. So those 2 1 mark questions will belongs to which particular topic. So we cannot predict like that. So whatever is there in your syllabus, okay. So you should not be in a mentality that I'll leave this chapter, I'll leave that chapters. If you're in that mentality, then you lose marks, and in 1 mark and 0.5 mark, it matters a lot in GATE exam, right? So you should be in a very selective study mentality. All right. So binary code weightage, I'm just telling you the facts. What are the things are happening in the exam? I'm just explaining you that. Then we have in latch. So what is the content that we learn in the latch? So in latch, students, so only 2 things. One is known as your SR NAND latch and SR NOR latch. SR NAND latch and SR NOR latch. So all the questions are coming from this particular concept only. And in NAND latch, students, there is something known as 0 0 input followed by 1 1 inputs. And in NOR latch, there is something known as 1 1 input followed by 0 0 input. So these are some special cases. If you see the questions of latch, so 100% of the question, I can tell you 100% of the questions, so that will be based on the standard truth table of this latch or based on this particular special cases. 100% of the questions are framed on these concepts only in SR NAND latch, NOR latch. Then coming to the chapter number 8, students, in flip-flops. So from flip-flops, you don't get many questions. I mean, flip-flop is like a basic building blocks to understand counters and registers. From flip-flop, usually you don't get many questions. But what you need to understand in this, the 4 kind of standard flip-flop, like SR, JK, T and D flip-flop. For all these flip-flops, what is the truth table, what is the state table, and what is the excitation table? You must remember this. So this you should know. And then sometime questions are coming on race around condition. And one more category is flip-flop conversion. How to convert one flip-flop to other flip-flop. So these are the 3 category that you should know. So sometime direct questions are asking, what is the state equation of this flip-flop, that flip-flop? If there is any question from flip-flop, so that belongs to any of these 3 category. What is race around condition, how to convert one to other flip-flop, and what are these property of this kind of standard 4 flip-flops. Then coming to chapter number 9, register, its weightage is also pretty less. Okay, its weightage is also pretty less, friends. In register, so what we get is, so they will be giving us some register structure like this, and it will have some initial condition, and then there will be some external logic gate will be connected, and they will be asking us after how many clocks the state will be, let's say 1100, or after how many clocks the state will be again 1011. This model of questions in register. So this model of questions, 90% of time they ask this model of questions. And apart from this, so very, like 1 or 2 times they have asked. So there are 4 kind of configuration: SISO, SIPO, PISO, and PIPO. In these 4 configuration, you need to remember how many clocks needed for what? To store the data and to retrieve the data. So how many clocks you need to store the data, how many you need to retrieve the data. So this is what in case of 4 kind of register. So you need to have this data. So what model of questions are based on this? I mean, this model is very frequent and sometimes questions are asked from this. So this is what all about your 9th chapters, and in the 10th topic, that is counters. Counters weightage is pretty high, students. Okay, in the entire course, which particular topic having highest weightage? The answer is counters. In counters, so counters are basically broadly of 2 types. One is asynchronous type counter and one is synchronous type counter. In asynchronous type counter, students, you should know what is up counter, what is down counter, and what is up down counters. So there are certain observation you should know, like the initial count of a counter repeats on integer multiple of mod number. So by observing a particular circuit, whether it's a up counter or down counters, so that kind of question they're asking. Or they'll be asking a counter having now the present state is 101, after 200 number of clock plus, what is the states? Such kind of questions they will ask. So here one model of question is to identify the up circuit, down circuits. And if you observe that up and down counters, so how does the frequency of the flip-flop related to the clock frequency? And how does the delay of the flip-flop are related to the clock frequencies? So such model of questions are coming in the asynchronous counter. In synchronous counter, so there is something known as ring counter, from where the questions are less. There is something known as Johnson ring counter. So from this sometimes questions are coming. And there is one more counter, so there is no name for this, that is the generalized counter I am saying. In the generalized counter, okay, so they will be giving you, like the counter is, the counter has to count a counting cycle 0, 0, 1, 1, 1, 0, 0, 1, and again 0, 0 like this. So design the counter using T flip-flop. They will say if there are 2 T flip-flops are used, what are the input to be connected to T flip-flop? So this is one model of questions we are getting from this synchronous counter. Other model of question will be, so they will be giving you a counter circuits. So they may give a counter circuit like this. Let's say this is TT. So, and okay, there will be some other additional hardware, and they will be asking you if the clocks are triggered, what is the counting cycle, or what is the mod number of this counter. So this kind of question they are asking. So that is what I mean by generalized counters. So broadly this one, and one more concept is the cascade connection of counter. So sometimes questions are coming based on cascade connection of the counters. Okay, so counter, so these are the 3 broad category, students. Asynchronous counter, so where you have to identify the pattern of the counter based on the circuit diagram. And in synchronous counter, you have ring counter, Johnson ring counter, and generalized counters. And most of the time questions are based on this generalized counter. So here again there are 2 models. One is based on a counting pattern, you have to design the circuit. Second model is based on the given circuit, you have to find the counting pattern. And other one is the cascade connection of various counters. Then coming to 11th one, students, finite state machine. So its weightage is very less in the GATE exam. So there are 2 standard models, only Mealy model and Moore's model. Okay, so the standard architectures of these 2 models you should know. But generally questions from FSM are very, very less. And whatever the questions they are framing, they are using the word FSM, but those questions can be easily answered using the concept of counters. All right, fine. Then in the next topic is your data converter. Okay, so in data converter, students, so what kind of question they're asking? In data converter, so they will be asking to find the output of the converters. So they will be telling you this is what is the resolution of this particular converter. For this particular digital input, what is the analog output, or for this particular analog input, what are the digital outputs. So that is one model of questions that is based on the output of converter. And sometime they're asking the question based on the flash type converter. So in flash type converter, so they're asking what is the hardware requirements, how many comparators needed, how many register needed, what is the structure of the priority encoders, what is the delay involved. So like that. So flash type, but sometime what is the output expression of this converter based on the inputs. So questions are coming from flash type converter. Sometimes questions are also coming from successive approximation register type converter. And you have the dual slope type converter, and you have the counter type converter. Okay, so these are the four kind of your analog to digital converter, and questions will come from which particular converter we don't know, but you should study these four. Okay, so anyone they can pick it up, and generally the questions are based on what is the conversion time, what is the delay involved, how many clocks needed. Such kind of questions are framed from this data converter topic. And next from the logic family students. So logic family, its weightage was good in the old days before 2016 when the syllabus is revised. From after that, so they removed a significant part of this particular topic. So now we have only CMOS. And its weightage is pretty good students, okay? Almost every year or every alternate year, one question you are getting from CMOS. So what kind of question they are giving? So they will be giving you a standard circuits and they will ask you what is the output expression. Some tricky questions are also being framed in 2019 and 20s. But it's a very small topic. Hardly you need 30 to 40 minutes to understand the concept. And almost all questions you can answer, using those 30-40 minutes of content, logic family. Okay, you have to just focus CMOS. So earlier DTL, TTL, I square L, ECL, so many these all contents were there. But these days it is completely removed. Next thing is your semiconductor memory. Next thing is semiconductor memory. So semiconductor memory, its weightage is pretty less, friends, very less. So here, but still sometime questions are coming. So you should know what is the difference between SRAM and DRAM. Static RAM and dynamic RAM, what is the difference? This is one model of question sometime they're asking. And second one is standard 1-bit cell of SRAM and DRAM. Standard 1-bit cell of SRAM and DRAM. So these are two things you should know. So students, in short, I have explained you what are the exact model of questions are being framed in this particular topic, right? So now, so in the next couple of videos, some important concepts and where there are some shortcuts and some interesting things or might be some exceptional cases. So those all points I'll be covering up now in some videos. So in case you are preparing for GATE exam and while you are doing this for the digital subjects, so these are certain models, friends, you should never leave. And later on, when you'll practice the previous year questions, I'm very sure you'll also understand. Anyone who is practicing the last 30-year paper, you can have your own experience or you can have your own set of this thing. What are the contents they're asking? Okay. So based on my experience, I have shared this. Anyone who will be going through those all questions with proper knowledge. So this is what the conclusion you will get. And students, from CS point of view, this topic is very important. Every year, one question compulsorily from number system. Computer science students particularly. Other branch, sometime coming, sometime not coming. But CS, every year, one question you're getting from the number system. Okay. So hopefully this is clear to you, students. So let us meet with some other video where I'll be explaining you some beautiful concepts. Thank you.